For today's lesson, we will be discussing about the point and interval estimate of population mean. So we will be estimating the population mean based on the samples that we have. So before we start, let's define first what is an estimate. So it is a value or a range of values that approximates the population value. So it can be a single number only, or it can be a range of values. And this now gives us an approximation of the value of the population or the mean of our population. Now there are two kinds of estimate. First is what we call as the point estimate, and then the second one is what we call as the interval estimate. So the point estimate is a specific numerical value of a population parameter. So again, point estimate, it is just a specific numerical value. This means it is just a single number. So that's why we call it as the point estimate. Now the sample mean or the X bar is the best point estimate of a population mean. So as what we know, in every population, it has its corresponding population mean, and if we get a sample, this gives us a sample mean. So that mean of the sample from our population is the best point estimate to use for our population mean. And also remember that during our discussion about the mean of sampling distribution of sample means, if we get the mean of all our samples or the mean of our sampling distribution, it will be equal to the mean of the population. So again, when we say point estimate, this is just a single value or a specific numerical value that gives us the estimation for our population mean. And the best point estimate to use is the mean of the samples. On the other hand, the interval estimate, this is also called as the confidence interval. So later you will encounter this term. It is a range of values used to estimate a parameter. So if the point estimate uses one value only, for interval estimate, we have this range of values. So this estimate may or may not contain the true parameter value. Now, in interval estimate, we have, or we're going to identify range of values, and then we will conclude that our mean lies between this range of values. So let's just have one example for the point estimate. So let's say Jackie wanted to know the average grade of the students in statistics. She interviewed 40 students and the results are shown on the right. So here are the scores. Now the question is, what is the mean of the grades of the students in statistics? Since she only interviewed 40 students, that means she just gathered sample from the population of all of those students enrolled in statistics. Now, in order for us to get the mean of the grades of the students in statistics, that means we're going to estimate the population mean using the point estimate. What we can do is we can just simply get the mean of the samples. Because again, like what I've said in the previous slide, the sample mean is the best point estimate for the population mean. So this 40 students here, this is the sample, and then all we have to do is just to get the average of that, or just identify the mean by adding all of these and then dividing by the number of data that we have. So if you add all of these, we will get 3,416, and then just divide it by the number of scores or the number of data that we have, which is 40. So therefore, we now have 85.4. So this mean of the sample can also be used as our estimate for the population mean. And this is what we call as the point estimate, because as you can see, there's only one value. We're able to identify one value that will estimate now the population mean. Now for the interval estimate, there are two cases. So first is when the sigma is known, or this is the population standard deviation. So first is when SD is known. So in interval estimate, we have what we call as the confidence level of an interval estimate. So it is the probability that the interval estimate will contain the true population parameter. Since we are giving here range of values, so this confidence level, this is the probability, or this will tell us how sure are we that the population parameter is really within the interval that we came up with. Now there are three confidence level that we're using, And for each confidence level, there's what we call as the critical values, also known as confidence coefficients. So these are the z-values that is used in describing the characteristic of a target population. When, again, the population standard deviation is known, the z-values are used. So in the problem, if you already saw that the population standard deviation is given, so we will be using z-values. Now, all you have to remember is just to memorize this 3 confidence level and their corresponding z values. So if the confidence level is 90%, the z value that we will use is 1.65. If 95%, 1.69, and if 99%, we will use 2.58. So this confidence level again tells us how sure are we that the population parameter is really within the range that we're going to identify. So 90% confidence, that means we are 90% sure that the population mean is within this range. Also for 95% and 99%. Now, you might be asking, is it better to use the 99% level of confidence? Because that means I am 99% sure that the mean is within this, or the population mean is within this range. Now, the answer there is no. Having 99% level of confidence will not guarantee us, or it's really not better compared to other level of confidence. Why? Because the higher the level of confidence is, the larger now will be our range. And if there are a lot of numbers present within our range of values, or the estimate interval, then the accuracy will be affected, because again, there are a lot of numbers. If it will be, or if we will have a smaller or lesser confidence level, we will have smaller set of values as well. Now, which among the 3 is usually used? So usually we're using the 95% level of confidence, especially if you're really doing a research, or if you really want to conclude something, then it's advisable to use the 95% level of confidence. Now, we also have what we call as the margin of error. So it is the maximum difference between the observed sample mean and the true value of the population mean. So again, maximum difference of our sample mean with the population mean, and we solve it using this formula. So this z here, this is for our critical value, which can be found using our level of confidence, and then we have here the population standard deviation, and then this one is our sample size. So this is the formula for the margin of error. Now, after you solve that, we can now write the interval estimate. So it is expressed as like this. So we have x bar minus the margin of error. So this is the sample mean minus the margin of error. And then we have mean, sample mean plus the margin of error. So this is now our interval. So this part here, this gives us the lower limit of our interval. That means that is the lowest value already of our interval. And then we have here this one. This is the upper limit. There. So what does this interval means? This means that our population mean is within this particular range. So again, this is how are we going to express our answer for the interval estimate. So for our first example, to determine the average weight of oranges, 100 oranges were weighed. The mean weight of the sample is 150 grams. Previous studies show a standard deviation of 40 grams. Find the interval estimate of the population mean using 95% confidence level. So in this problem, we are going to identify the interval estimate of the population mean using 95% confidence level. So there are steps that we have to follow. Step number 1 is for us to identify the variables that we need. So what are the variables that we need? So you can just read the problem and then see what are the things that we can identify from the problem itself. So to determine the average weight of oranges, 100 oranges were weighed. So that means that is our sample size. So the sample size now, n is equal to 100 because there are 100 oranges considered in this particular problem. The mean weight of the sample, so it was already clearly mentioned here that the mean weight of the sample is 150 grams. So that is our sample mean. So the sample mean, or the x bar, is 150. Previous studies show a standard deviation of 40 grams. So this statement here, it tells us that the standard deviation of the weight of the oranges is 40 grams. But this is for the population, not from the sample of 100 oranges. So we can write here population standard deviation, or our sigma, is equal to 40. And then lastly, the confidence level that we have here, confidence level is 95%. So these are the things that we can get from our problem. So this is the first step. So to identify the variables that we can identify from our problem. For step number 2, we have to identify now the critical value to use, or the z-value. So we will be using the z-value since from the problem we can see that the population standard deviation is given. And in identifying the z-value, or the critical value, we have to consider also the confidence level. So since confidence level is 95%, so therefore, just look at the values that I gave a while ago, the 3 values there. Since confidence level is 95%, the critical value, or the z-value that we will use, should be 1.96. So again, this is now the value that we will use. Next, step number 3. So for step number 3, we have to solve now for our margin of error. So the formula for the margin of error, so we have the critical value and then multiply it to the population standard deviation divided by square root of our sample size. So you just have to substitute. So we have 1.96 times our population SD is 40 divided by square root of 100. Just plug this in into your calculator, round off to 2 decimal places, so we will get margin of error of 7.84. And lastly, for our step number 4, so we will now write our interval estimate. So it's sample mean minus the margin of error and sample mean plus the margin of error. So you just have to substitute here. So 150 minus 7.84. And then the upper limit is 150 plus 7.84. And then all you have to do is to simplify this. So we have 142.16 as the lower limit of our interval, and the upper limit is 157.84. So this is now our final answer. So what does it mean? It means that the population mean is within the values 142.16 up to 157.85, given that our confidence level is 95%. And so this is how we solve for the interval estimate of the population mean. So first step again is for you to identify the variables needed. Step 2, solve for the, or identify the critical value using the confidence level. Step 3, identify the margin of error. And then step number 4, write now the interval estimate. Another example. In a study of 50 senior high school students, the mean number of hours per week that they played video games was 20.5 hours. It was estimated that the population standard deviation was 3.7. What is the 99% confidence interval for the mean time for playing video games? So, step number 1, identify the variables. So first that we can see here is there are 50 senior high school students. So that is our sample size. So n is equal to 50. Then after that, the mean number of hours per week that they played, so they refers to the 50 senior high school students, was 20.5 hours. So that is our sample mean. Sample mean, or our x bar, is equal to 20.5. It was estimated that the population standard deviation, so it was mentioned here, population standard deviation was 3.7. So that is our population SD, or our sigma, that is 3.7. And lastly, our confidence level is 99%. So 99%. So again, we're done listing our variables. Step number 2 is to identify the critical value to use. So to identify the critical value to use, just refer to the values that I gave a while ago and then look at our confidence interval or the confidence level, which is 99%. So since the confidence level is 99%, therefore, the critical value that we will use, or the z-value that we will use, should be 2.58. Okay? Again, we are using z-values since the population standard deviation is given. After this, let's solve for the margin of error. So step number 3. Step number 3, solve for the margin of error. So that is 2.58 times the population SD, 3.7, over square root of sample size, which is 50. Again, plug this in into your calculator, round off to 2 decimal places, you should get 1.35 as our margin of error. And then for our last step, step number 4, so let's now get the lower limit and the upper limit of our interval. So we have the mean, which is 20.5, minus standard, or our margin of error, 1.35. And then 20.5 plus margin of error. So therefore, the interval now that we will get will be 19.15 up to 21.85. So this means that we assume, or we estimate, that the mean, the population mean, is between 19.15 up to 21.85. So it's within this range, given that our confidence level is 99%. So again, these are the steps that you will use, or you will do, if in case you want to identify the confidence interval or the interval estimate, given that the population standard deviation is given. Now, if the population standard deviation is unknown, let's say the sigma is unknown, so we will be changing some of the steps in our solution in identifying the interval estimate. So when the sigma, or the population standard deviation, is unknown, the interval estimate can be determined using student's t-distribution. So what is student's t-distribution? So last time we used the z-table, so we have what we call as the t-table, or the student's t-distribution. So this gives us now, or this will give us now, the critical values that we need for our solution. So let me show you an example of a t-distribution. So here is an example of a t-distribution. So as you can see, we have here a lot of values. We have different columns for specific values. We have degrees of freedom, we have the n, and then we have here the confidence coefficients. So we still have the 90%, which is 0.9 here, 95% of confidence level, or 0.95, and 0.99. So later I will explain how to use this using examples. Now, in our t-distribution, we are using degrees of freedom. So the degrees of freedom, or DF, are the number of values that are free to vary after a sample statistic has been computed. The degrees of freedom is computed as follows. So we have to identify first the degree of freedom before we can identify or use the table that I showed you a while ago. Because as you can see there in the table, we have a specific column for the degrees of freedom. Okay, so how are we going to identify the degrees of freedom? So all you have to do is just to subtract 1 from n, or it's just n minus 1, where n is the sample size. So this is how are we going to compute for the degrees of freedom. And after that, we also have what we call as the margin of error. So we still have the margin of error here. So the confidence coefficients, or our critical values for the t-distribution, is found in the t-table. So that is where are we going to identify the critical values to use. So here is now the solution, or the formula for the margin of error. So this is the confidence coefficient or the critical value or the t value, which can be found in the t table. So later again, I will show you how are we going to identify the value of t. And then this S right here, since we don't have the population standard deviation, we now have S, or that is the sample standard deviation. So S, we use it to denote sample standard deviation. And then we still have in the denominator square root of n, which is again our sample size. And for the interval estimate, so it's still the same as the other one. So we still have to subtract and add the margin of error from our sample mean. So let's have this example. A random sample of 30 students were measured about their height. The average height of the sample is 5.3 feet. The sample standard deviation is 1.1 feet. Find the interval estimate of the population mean using 95% confidence level. Now, let's list down. So the steps are just the same. So first, let's list down all of the variables that we can get from this problem. So first, we can see here a random sample of 30 students. So that will give us our sample size. So the sample size that we have, n is equal to 30. Then the average height of the sample is 5.3 feet. So that is our sample mean. So x bar is equal to 5.3. And then after that, we have this statement, the sample standard deviation. So here, sample standard deviation is 1.1 feet. So that gives us now the sample SD, or the sample standard deviation, which is denoted by S. So equal to 1.1. And our confidence level is 95%. Now, how will you know which of the two should we use? So in this problem, you will see that the standard deviation given is from the sample. So if the standard deviation given is from the sample, so this is the one that we will use, which involves now the t-distribution. But if the population standard deviation is the one that is given, so we will stick with the z values that we have a while ago. Okay? Next, step number 2. So we have to identify the critical values. Now, since we don't have the population standard deviation, we will be using the t-distribution for the critical values. So first step that we have to do is to solve for the degrees of freedom, which can be solved by n minus 1. So n is 30, then minus 1. So our degrees of freedom is 29. Okay? Now, from there, we can now identify the t-value that we have to use. Remember, our degrees of freedom is 29. Our confidence level is 95%. So now let's go to the table. So here in the table, so you have to look at the degrees of freedom. So this one is the degrees of freedom. And then you just have to identify where is 29, because that is our degrees of freedom as we solve. So here is 29. And then here you have the confidence coefficients, and then based on our problem, it's 95% confidence level. So we will be choosing this one, 0.95. And then you just have to identify where did the two intersect. So we are looking at the middle one, this one right here, 29. So the value that we will use is 2.045. Okay? So again, the degrees of freedom is 29, confidence level is 95 or 0.95. So the value that we will use is 2.045. So that is now the value that we will put here, 2.045. And that is the one that we will use for our margin of error. So step number 3. So you have the margin of error. So t, so that is t and then sample standard deviation over square root of n. So just substitute 2.045 times sample SD is 1.1 and square root of n, square root of 30. So just solve this and then we will get a value of 0.41. So that now is our margin of error. And then last step, so to write now the interval, so sample mean minus our margin of error, and then sample mean plus the margin of error. So if we simplify this, we will get 4.89 up to 5.71. So this is now our interval estimate, or the confidence interval. That means we estimate that the population mean is between or within these two values, 4.89 up to 5.71, given that our confidence level is 95%. And for our last example, Rochelle wants to know the mean of all entering trainees in a boot camp. The mean age of a random sample of 25 trainees is 18 years, and the standard deviation is 1.3 years. The sample comes from a normally distributed population. Find the interval estimate of the population mean using 99% confidence level. So step number 1 is to list down all of the things that we know from this problem. So what we have here is that the mean age of a random sample of 25 trainees. So there are 25 trainees, so that means that is our sample size. N is equal to 25. And then the mean age is 18 years of those trainees. So that is our sample mean. Or X bar is equal to 18. And the standard deviation is 1.3. So it still pertains to the 25 trainees. So that means that is our sample standard deviation, or our S, which is 1.3. And our confidence level is 99%. Step number 2, let's identify our critical value. So first, we solve for the degrees of freedom. And that is n minus 1. So 25 minus 1. So 24. So that is our degrees of freedom. And then from there, we can now identify the t-value. So let's go back to the table. So you have to look again at our degrees of freedom. So we have 24. So this one. And our level of confidence this time is 99%. So we will be looking at this column for 0.99. So we have this one, 2.797. So that is now our critical value, or the t-value. So let's write here 2.797. And then again, let's solve for our margin of error. So E is equal to 2.797 times sample standard deviation of 1.3 over square root of 25. So just input it in your calculator, and the answer that we should get is 0.73. So that is our margin of error. And then step number 4, just plug in into our last formula. So sample mean minus margin of error, and then sample mean plus margin of error. So we have now 17.27 as the lower limit, and upper limit is 18.73. So there. Now this range here serves now as our interval estimate of the population mean using 99% of confidence level. It means that we assume, or we estimate, that our population mean lies within this particular range. So that's it for today. I hope you learned something about how to identify the point and interval estimate of a population mean, when are we going to use the z values, and when are we going to use the t values. And see you next time.